Hey everyone, welcome to today's Explainer. We're diving straight into what is, without a doubt, the single most dangerous misconception in AI-assisted engineering right now. Look, if you're using AI to write code, design architecture, or debug systems, you absolutely have to understand the silent risk that's just lurking inside these tools.
So, let's kick things off with a question. It might sound a little, philosophical, but trust me, it is incredibly practical. Does AI actually know things? I mean, we all kind of treat large language models like this omniscient magic box, right? We ask them super technical questions, and then we just blindly trust these highly authoritative, confident answers they spit back at us. But is there actual knowledge inside that box?
Well, no, there isn't. An AI does not know things the way you or I do. It's not looking up answers in some pristine, perfect database of facts. Instead, it generates answers, token by token. At its core, it's really just a statistical word predictor. It is totally not a fact checker.
Okay, here is our roadmap for today. First, we'll look at the magic box myth. Second, hallucination, which is that silent risk I mentioned. Third, real risks in engineering. And finally, we'll cover the verify, don't trust loop.
All right, part one, the magic box myth.
To really wrap our heads around the risks of AI, we need to get our technical vocabulary straight. And that starts with the absolute core building block, the token. Basically, a token is just a chunk of text. On average, it's roughly 3/4 of a word. When an AI reads your prompt or generates an answer, it isn't actually reading human words at all. It's processing and generating mathematical tokens. To put that into perspective, if you have a 1,000-word document, you're looking at roughly 1,300 tokens.
Now, here's where it gets absolutely crucial. We have to understand the massive difference between pattern matching and fact-checking. Look, a large language model has read a huge fraction of the public internet, sure, but it is purely a statistical pattern matcher. The whole system completely lacks a fact-checking step. It has no way to verify if its output is actually true in the real world. Our source material has this absolutely brilliant analogy that hits the nail on the head. Imagine a developer who has read literally every Stack Overflow post, every documentation page, and every GitHub repo. But they've never actually run your specific code base. They don't know your internal APIs, and they literally can't check if what they're saying is true right now. Guys, that is exactly who you're collaborating with when you use AI. It can write beautiful, fluent code for a real API that simply doesn't exist.
Which brings us to part two, hallucination. The silent risk.
Let's formally define what we're dealing with here. Hallucination happens when an AI generates text that sounds completely plausible. It fits the pattern perfectly, but it's actually completely false. Because it doesn't have that internal truthometer, it just spits out the most statistically likely next token with total unwavering confidence. And it's so vital to realize here, the AI isn't lying to you. It's not being malicious, it just has absolutely no idea that it's wrong.
And here is a slightly uncomfortable truth that we all absolutely must internalize. Hallucination is not a bug. It's not something that's just going to get patched out in the next software update. No way. It is a fundamental property of how language models work, period. As long as they operate via statistical pattern matching, they are going to hallucinate. Understanding and anticipating that limitation, that's exactly what separates the really good AI users from the downright dangerous ones.
So let's move to part three. Real risks in engineering.
Let's actually look at the real blast radius of these hallucinations. Say the AI invents a method or a class name. That is a high risk. Why? Well, because it might compile perfectly fine, but then it fails silently at runtime. Or what if it invents library version features? It might hand you a perfect method for version 3, but oops, you're running version 2. And then there's PCI or compliance advice. This is a critical risk. The AI sounds incredibly legally authoritative, but it could be disastrously wrong.
Here's a really perfect example of this in action. Take a look at this hallucinated output. The AI confidently suggests this method called getDeclineReasonAsync. I mean, it looks gorgeous, but that method absolutely does not exist in the SDK. If you just copy-paste and trust it, your app is going to crash. But then contrast that with the grounded output right next to it. This one is based on actual documentation provided directly to the AI. The difference in reliability there is just night and day.
All right, on to our final section. Part 4, the verify, don't trust loop.
Before we jump into the actual loop, we really have to talk about your single biggest quality lever, which is grounding. Grounding essentially means giving the AI actual hard facts to work from. So instead of asking it to just magically invent a solution out of thin air, you paste in your actual code,
your specific error messages, or your real log lines. You're basically forcing the model to reason about real data instead of letting it drift off into its own invented statistical patterns. But listen, grounding alone isn't quite enough. You need a solid process. Enter the 4-step verify don't trust loop. Step 1, the AI generates the code or advice. Step 2, you read it critically. Never, ever treat it as gospel truth. Step 3, verify the specifics. Actually go check those method names and library versions. And finally, step 4, run your tests. Hit the compiler, run the unit tests. You only ship once you've successfully passed step 4.
In this complete workflow, notice how trust is entirely removed from that initial generation phase. You're just treating the AI as a highly fluent guesser. The verify specific stage, that is where your actual engineering happens. Implementing this end-to-end framework is exactly how you turn risky, casual AI usage into robust, professional software engineering.
I really want to highlight this incredibly practical rule of thumb, straight from our sources. Any method name you don't already know, check the docs. This adds 30 to 90 seconds and saves hours of debugging. Just let that sink in for a second. Spending a minute to check a documentation page is not overhead. It is literally the absolute cheapest verification available, especially compared to getting a frantic on-call pager alert at 2 a.m.
Ultimately, trust in AI is not a simple binary switch. You don't just trust AI or distrust AI. Trust is something you build incrementally through repeated verification cycles. You have to calibrate your trust based on your own accumulated evidence and the specific type of task you're tackling. Never, ever base it on the artificial confidence of the model itself. Start with low-stakes boilerplate tasks, observe the error rates, and then adjust how deep you verify based on reality.
So I want to end today's explainer by leaving you with a bit of a provocative question. If hallucination is a fundamental, permanent feature of large language models, and trust me it is, what AI output are you going to stop blindly trusting today? The magic box might be a myth, but with grounding and that verify don't trust loop, you can absolutely turn a risky guesser into an incredibly powerful engineering tool. Thanks so much for joining me, and I'll see you on the next explainer.